morning, students. We will start with parallel processing in computer system architecture. We studied till the instruction architecture, and after that we discussed about the how instruction are carried out. Okay, so there are two type of cycle called instruction cycle, instruction fetch, and instruction execution. Okay, after that the cycle repeats. Each time an instruction is first fetched, then it is executed, and this way all the instructions are carried out. This cycle repeats. Okay, this is how instructions are executed in by a processor in a computer. Okay, so now the question arises that how to reduce the timing, how to improvise the process in such a way that time is reduced. Okay, so what we do is, suppose there are 100 instructions. Okay, it will take, suppose one instruction take 10 nanoseconds. So how much time, total time will be consumed? 100 into 10 nanoseconds. So if we perform all these instructions seriously one after another, first instruction 1, then instruction 2, then instruction 3, each will take 10 nanoseconds, and this will go on until I100, and it will take 10 nanoseconds as well. So in total, how much? 1000 nanoseconds takes place. 1000 nanoseconds are required to complete the entire 100 instruction one by one serially. Okay, so can we reduce this time is the question. Can we improvise the time is the question. Okay, now what is parallel processing? Parallel processing means you have multiple processor, and within one instruction time you can carry out all the 100 instruction. That is called parallel processing. So I'll explain further. Let's see. Suppose instead of serially, if we do parallel, so there are 100 processor, P1, P2, this is P100. Now this will carry out instruction 1, this will carry out instruction 2, and this will carry out instruction number 100. Now 100 instruction, instruction 1, instruction 2, all of them are being executed simultaneously. How much each instruction takes place? How much time does it take? 10 nanoseconds. So here within 10 nanoseconds all the instructions are being executed. Why? Because all are executing simultaneously. This is called parallel processing. Parallelly every instruction is being executed. But what is the problem here with parallel processing? It requires too much infrastructure, that is too much hardware. 100 processors are needed. Processors are needed. So this is a drawback. What is the drawback? Drawback is too much hardware implies too costly. It is very expensive. It is not feasible even. Okay, so that's why if we continue, if we execute instructions serially one after another, time is more. Here time is too less, but it is too expensive. Within 10 nanoseconds we can execute 100 instructions. But what is the drawback? 100 processors are needed. That is too much expensive. Okay, so that's why we chose a middle path, so that we can a way out through which we can reduce the time, and we do not even need much hardware. That type of thinking we have to build in order to solve the problem, which is feasible. This is also solving the problem, but it is infeasible. Why? Because eventually you are causing a loss. You have to spend too much. So that's why we opt for linear pipelining. Linear pipelining. linear pipelining is the method. Okay, now to understand this, first we have to understand how an instruction is executed. I told you that first an instruction comes into picture. First we have to take the instruction and fetch it. So first we have to fetch the instruction. Then we execute the instruction. Okay. So there is instruction fetch, instruction execute. These are the stages you know about and the cycle repeats. Okay. But now I will add a further few more things. We will see how instruction is executed in a more detailed manner. Okay. So there are not just two stages. This is broad sense. In the broad sense, broadly we can say there are two stages. But actually, if we closely look at it in a detailed manner, we have usually 4 to 5 stages. Okay. So what are those stages? First, instruction is fetched. In any instruction, suppose this is an instruction I1. Then we have to decode the instruction. Instruction decode. Okay. Then we have to, execute. Then we have to write back. So what are the stages here? First we have to do instruction fetching. Then we have to do instruction decode. Then we have to perform execution. Then we have to write back it. Okay. We studied it. We have already studied it. You can go through the previous lecture in which I explained you how an instruction is carried out. Broadly, we can classify it as fetch cycle and execution cycle. But in a detailed way, there are 4 stages, generally 4 to 5 stages. There is also a stage called operand fetch, which is optional, but I am trying to make things simple for you. Okay. Because we can also add operand fetch. What happens in these stages is I'll just quickly revise for you. Okay. In instruction fetch, we need to fetch the instruction, take up the instruction. The program counter will tell us that this is the address where you have to get your instruction, next instruction. So we fetch it. First we fetch it. After that we decode it. We have to understand what is the opcode, what is the operation, what addressing mode it is, how to take the operands. Okay. So this is done in instruction decode. Okay. Then in operand fetch, we have to fetch the actual operand. Okay. Given the addressing mode, the type of addressing mode, whether it is immediate addressing mode or whether it is register addressing mode. Okay. Accordingly, we have to get the operand eventually. Once we get the operand in the operand fetch phase, we will then perform the operation. That is called execution. We have to perform. If the opcode is given is addition, then we have to add it. If the opcode is division, we have to divide it. Okay, accordingly we have to perform the operation. After which we have to do the write back. Write back means you have to store the result accordingly. If the storing of result is to be done in memory, we do so. If it has to be loaded in a different register, we have to do so. Okay. So write back is all about storing the result in the appropriate place. Okay. So this was all about stages of an instruction. How an instruction from fetching to the end of execution happens has been defined in all these stages. Okay. So I hope it is clear. Now we will find significance of these stages and we will see how it makes sense with relation to pipelining. Okay. How pipeline makes use of these stages and how we can reduce the timing is our aim. Okay. Because we want to do what? Linear pipelining here. All our aim is to reduce the time. We don't want to execute instructions serially. We want a way out without using too much hardware. We want to reduce the time. That's our aim. Okay. So what happens is in pipelining, although we do not execute parallelly, suppose this is the timeline. Okay. How timing is reduced I am trying to show here. This is first clock cycle. So this is I1. Instruction 1 is fetched. So it will go through what kind of stages? First instruction fetch. Then instruction decode. For simplicity I am taking 4 stages. Okay. execution, then write time. So this is one clock cycle, this is one clock cycle. So I am writing this 2, second clock cycle, third clock cycle, fourth clock cycle. Okay. So this is called the number of stages in a pipelining, which is defined as K. K stage pipelining. So what is the number of stage here? 4 I have taken. Okay. Now second instruction. I need your absolute attention in this case. In the second instruction, we can't do it parallelly. Why? Because we do not have a different processor. If our processor is busy in fetching, we cannot make it fetch another instruction at the same time. Okay? Because there is only one processor. We do not want to increase the hardware, remember? So what we can do is, we can fetch here. Okay? So, in first clock cycle, the processor is fetching instruction number 1. In the second clock cycle, the processor is decoding and fetching instruction number 2. Getting it? So, now this circuit is not simultaneously busy with 2 or multiple instruction. Okay? It is always busy. Instruction fetch is always being busy. We are making it busy. The instruction fetch circuit of the processor at first clock cycle was working on instruction 1. In the second clock cycle, it is working on which? Instruction number 2. You are getting the idea, right? So we are making the processor busy. Every component, every stage of the processor must be busy doing some work. That is the idea. That is called linear pipelining. We are parallelly doing things, but also we are, since processor is one, we are doing things linearly as well, one after the another. So instruction fetch is first fetching instruction 1, and then it is fetching instruction 2 at the second clock cycle. But at the same time, the decode circuit at the same time, and means at the second clock cycle itself, fetch is doing some work and decode circuit is also parallelly doing some work. What is decode circuit is doing? It is decoding the first instruction, and at the same time the fetch circuit of the processor is fetching instruction 2. So this is called parallelly working. This is linearly working. Each stage is linearly working. But what is pipelining? Pipelining means parallelly we are doing something. So what is parallel in this sense means? Parallelly we are decoding also in the same time, fetching also in the same time. Okay? I hope you got the idea. And similarly, instruction decode of second instruction start in third clock cycle. That means in the third clock cycle, execution of first instruction is being taking place, and at the third cycle, at the same time, decode of instruction 2 is also taking place. Okay. Similarly, you got the drill, right? Execution is being take place at the fourth clock cycle of I2, and write back of I1 is being carried out at the fourth cycle itself. Then in the fifth clock cycle, this is completed. That is, I2 is being completed fully. So in the fourth clock cycle, I1 is being completed. In the fifth clock cycle, I2 is being completed. Suppose I3 next. Then we have to start like this. Instruction fetch, instruction decode, execution, like that. Okay. So this is how things happen. Now, let us check whether the timing is being reduced or not, because then that's our aim. Okay. So if in case of serial, what would have the time taken? Suppose one instruction take here 4 clock cycle. So in case of serial, 4 into 3. Since we are executing 3 instructions, so 12 clock cycle needed. Now in case of pipeline, let's check. In case of pipelining, these 3 instructions take how much time? 6 clock cycle. Isn't it? Within 6 clock cycle, we are completing 3 instructions. So it is reduced. This is being reduced. So I hope you understood the benefit of pipelining. Using only one processor, we are able to, reduce the timing of executing the instruction, multiple instruction. Okay. So this is a very powerful technique. So this was all about introduction to linear pipelining. Okay, we will understand and we will further dig into this more, but I want to show you this in terms of a formula which is very important. This is the pictorial representation, but suppose there are k number of stages. Suppose 5 stages and number of instructions are suppose 100. How much time will it take with non-pipelined structure, that is serial structure, and with pipeline structure? We will compare, okay, in case of large number of instructions. For that matter, we have to use a formula, and I will tell you what the formula is. So, with pipeline structure, time taken for n instruction is equal to k plus n minus 1 clock cycles, CCs. Okay. So this is the formula, k plus n minus 1, where k is the number of stages, n is the instruction number. So number of clock cycle needed is this much. Now if someone asks about time, okay, what is the time taken in terms of nanosecond or milliseconds, then what you can say, you have to define what is the clock cycle, what is time period, okay. If one clock cycle is suppose 1 nanoseconds, then you just have to multiply the number of cycles, number of clock cycle into TP, time period, okay. What is time period? Time period is the time of one clock cycle is called time period. So this is the time in seconds. Second is the standard form of time, so I am writing in second. It may be asked in millisecond, nanosecond, and whatever. Eventually, seconds you need to know. Okay. So this was all about pipeline time. How much time is needed for multiple instruction to be carried out. Okay. Now with time with non-pipeline or serial structure is, you can know, and into the number of instruction into time for one instruction. So this is what common sense is. If one instruction takes place in serially, one after another, we are executing instructions. So if one instruction takes place, suppose takes 10 nanoseconds, then 100 will take what? 100 into 10. Simple multiplication. Okay. So this is time for serial and this is time for pipeline architecture. Okay. So we will discuss further, or we can discuss this in detail in the next class. And if you have any doubt, you can post it in the comment section. You can reach me through WhatsApp or Gmail. Okay. Thank you. That's all for today.